I think that people, just being human beings, are curious. We want to understand in what universe do we live, how is it shaping, evolving, what is its future, what is the fate of the universe. It really comes down to a very, very fundamental question about our place and where we live.
We establish a cosmic context for mankind.
Humans have always wanted to know what their surroundings look like, and telescopes provide the ability to do that.
It's one small step for man, one giant leap for mankind.
This work is a way for us to learn about our one universe. So what is its future? What is its fate? Walking into the dome to see the telescope itself is always a feeling of a bit of awe. One thing I really like to do every night that I go observing is to make sure to watch the sunset, but also look at all my surroundings. You know, it helps to add some perspective. I think going in person observing is important to also kind of remind ourselves of our place in the universe. So to me, observing is not just gathering data, it's also an experience, like as a human, and it's also a connection to the universe. So an observing night doesn't actually start at night. It even starts earlier in the afternoon because we have to take a number of calibrations. So we have to characterize the instrument's property, the optics property. Hey guys, everything good? There is that feeling of being an explorer because sometimes, you know, I start getting ready to work and I think, oh, maybe today I'll find something that I'm not expecting. DESI is a Dark Energy Spectroscopic Instrument, and it was built at the Lawrence Berkeley Lab in California, and then it was mounted in the telescope here on Kitt Peak in 2019. And it was built specifically to conduct what is called a Stage 4 Dark Energy experiment. One of the biggest mysteries in astronomy right now is dark energy. Dark energy is the name that was given to the phenomenon of the expansion of the universe happening at an accelerated pace. It's this force that's pushing everything apart. It's stretching space-time. So we know what it does, and we know that the majority of the universe is made out of dark energy. But exactly what is it? We don't know that yet. So the instrument needs to make the largest ever three-dimensional map of the universe. This is the way we're going to learn more about dark energy.
So this instrument, the Dark Energy Spectroscopic Instrument, it has the ability to measure 5,000 different galaxies, all within about a 3-degree field of view, all at once. It measures their spectra, which means it takes the light and it splits it up into many different wavelengths. And from that fingerprint, we can tell how far away these objects are. NOIRLab is the National Science Foundation's laboratory for optical and near-infrared astronomy, ground-based astronomy. It's been our job to maintain the telescopes, make sure the operations go smoothly, etc., and keep them operating every night. The thing that makes DESI possible is this rather remarkable feature in the early universe. So very early in time, right after the Big Bang, the universe goes through a very rapid period of expansion called inflation. And after that point, the universe is extremely smooth, but it has tiny little perturbations in density, and those perturbations grow. And it's those ripples, these sort of spheres in the universe, where we have a slight overdensity of galaxies. So DESI tries to make a measurement of these spheres in the sky basically from the present day back in time to about 12 billion years, and try and map how these spheres have changed. And that's what we call our standard ruler.
So what we can do is create computer simulations of basically a simulated universe. So if we want to simulate, let's say, 5 or 10 different universes with each a different version of dark energy or different versions of gravity, each will predict different 3D structure. And then we can compare with the real observation that we do with DESI to basically determine which model is correct. If dark energy is constant, which is the model we've had in mind for 25 years, it means that the dark energy is the same, which means that the acceleration of the universe expansion would continue forever. So it means that all galaxies become so far apart from each other that it's impossible to even see another galaxy. But if dark energy does get weaker with time, it could be that the expansion of the universe slows down eventually. So instead of being always accelerated, it could stabilize. And the more extreme case, it could slow down to the point where it stops completely expanding and collapse onto itself again. So it's this balance between matter and gravity going one way and dark energy going the other way that will dictate the final location of all galaxies in 3D in space-time. So with DESI, we made an initial measurement, and we actually had a surprise that no one was expecting on the team, which is that dark energy seemed to deviate slightly from being a constant, meaning that dark energy is changing or evolving. And in fact, there's a possibility that dark energy is weakening with time.
The results have been fabulous. I mean, we couldn't have hoped for a more interesting time. So this acceleration is slowing down. It doesn't mean we've started decelerating. It just means that we're accelerating more slowly. So there's been a change to how the acceleration has changed with time, which is different from what we thought back in the late 90s. So what does that mean? It means that the future of the universe is sort of up for grabs.
One thing that I find hard to wrap my mind around myself, even as an astronomer, is really the sheer distances. It's just the immensity of the universe. It's beyond anything that we, experience as humans. And thinking about this, even if it's my job, is still sometimes a challenge.
We often think that astronomy is an old field and we know a lot about the universe, but in reality, we're very much in a discovery mode.
This nation has the resources to undertake such exploratory ventures.
Perhaps this universe will expand forever and slowly get fainter and further away. If the universe manages to turn around and we go back through another oscillation, well, it would be a different kind of an end for everything that currently exists in the universe. But for science, there has never been a final answer. It's always been a new horizon that we want to get to or understand. It's the mystery that keeps you going, and finding the answer to the mystery is incredibly satisfying, whatever that answer may be. I think we have a lot of mysteries that we're trying to solve, and that in itself is an incredibly exciting thing to look forward to.